Academy 2026 behind the booth, inaugural booth crawl. We are here with Peter Verrillo, Redefine Surgery. Welcome to New Orleans, sir.
Thanks for having me.
We got quite a team assembled here around you to hear about this. We've been watching the journey of Redefine over many years. Super excited. We know there's some announcements out this year of cool new things. Can't wait to hear about it.
Oh, thanks so much. So first off, we're developing what we call motion-enabled guidance, and we call it MEG. MEG is a megalodon shark, but she's a baby shark. She's very friendly, but she eats makos for breakfast, right? So the reason why I say that is that a typical robotic procedure can take very long. Even in the hands of experts, it can only get down to about 17 or 18 minutes. And that's still a very fast procedure. But with the technology we're developing, we see it going even faster and shorter. First off, we're using an optical system. Unlike a lot of other systems you may have seen, this is not structured light. So the camera is just using very low cost, high efficiency vision, stereoscopic, and it actually tracks. This moves back and forth as the knee can move back and forth. So you don't have to worry about where it's positioned because it'll find where you are during the surgery. Quick walkthrough of the procedure. We'll do a knee today. We're going to do a KA knee. And the first thing we have to do is place this little instrument inside, pin it down, and then run through a range of motion like you would typically do to find the center of the femoral head. I normally lift this out and do those kinds of things as well. From that few seconds of video, we're then able to compute where the femur is, where the instrument is, and to your pre-op plan or to an intraoperative plan we're going to do next, where this base is in three-dimensional space. We then look at the cartilage. Unlike anyone has ever looked at cartilage before, we're able to map it in 3 dimensions and understand depth of the cartilage. We take 2 quick confirmations on either from your judgment, your eyes, or with a depth gauge, and you'd make those adjustments as needed. And then based on a 9mm thick resection, which most companies are around there, you'd have your cut.
So there's no imaging before this?
In the first version, we'll have CT based,
okay.
But as soon as we get that cleared, we're going to submit the non-CT. We actually have so many points taken here. When we compare that to our validation of with an $80,000 camera that takes 20 minutes to scan the whole thing, we're almost seeing the exact same result. So what we're able to do with just a few seconds of computation is becoming equivalent to like really expensive industrial level measurement cameras. Another thing we're doing a little bit different is around patellofemoral tracking. So when you typically place a knee using kinematic alignment, you're trying to optimize the distal thickness, the posterior thickness, but also you don't want to ignore where that track is. Not every implant is the perfect fit to the patient. And that's why people have tried to solve this with custom implants. So you can make your adjustments here to track to the patella track, make your adjustment on flexion extension, and then you get the traditional view that you're used to if you're a Mako user or a robotic user, just with a little bit more friendly look and get a quick look at what dimensions matters to you. Now this is the fun part. We're going to come over to the robot. So the robot is now making a micro adjustment that's precisely where you're supposed to put the distal pins. So we know where this is, and we just move this robot so we can put the pins in at the right spot. And we're going to take this instrument and slide that on. It's going to lock in.
This would be sterilely or not?
This would be sterile back table on the scrub tech. There'll be a drape over this and magnetic pieces on top. So the magnetic pieces will come sterile. And this comes off and we'll slide onto this instrument.
So what just happened?
This happens every single time. So you're not the first person to ask that. So this robot makes a micro adjustment that tells you exactly where this was, like we know where this is, and this is in the same exact spot there, and then it moves this piece to the exact place it needs to be to put the distal pins in. So when this comes on, we now put those 2 pins through, and they're exactly where they should be to make that cut that you had planned intraoperatively.
How long did that take normally? Like in real world, how long will that take to do what you just did?
We slow it down because we have to explain it to people. So that few seconds of adjustment is all it takes. Yeah. We actually thought there'll be a slow mode in the beginning where people understand it and recognize it, and then eventually they can skip that and just go right to it, because it's just a second or two.
How much information do you need about the actual implant before you start all this?
So that's a good question. We're partnering with the device companies directly, so we know everything about it. We have the CAD models and we can place it properly. And ultimately give that position with an understanding of where the map is, where the patellofemoral track is, where the patella is. Once the 2 pins are on, we take their traditional cutting guides from the manufacturer and slide that down to make the distal cut. And then there's one more adjustment for the femur, which is to place your 4-in-1 guide, right? So you could eyeball it, you could put it on and just place it where you felt, or you would just take one more step on the robot and adjust an instrument that looks like this, that handles internal, external rotation and translation. And that would ultimately slide down and have the pins in the right spot for your distal cutting guide. And that's kind of what's shown here.
Did the robot do anything with that?
Not just now, we skipped that part.
Oh, okay, but it would do something with
Yeah, the robot basically
Rotation.
allows you to put this where it needs to be and handle height, anterior, posterior, and internal, external.
Do you know anything about the balancing of the knee before this is done, or you're going to just balance it later?
So for KA, traditional KA, they like to put the femur where they put the femur and then balance on the tibia. So it's a great question because that's what's coming up next. So we put some pins in along the side,
How were those placed, with a guide or a normal guide, or what were you placing the pins with?
somewhere in the side. It's got to be in the ballpark because the robot's going to make a micro adjustment on the pins. So you just need to put it in about the right place. Now we have started testing a laser beam that'll shoot down and show you where to put it so you can get it about in the right spot.
Sharks with laser beams.
Sharks with laser beams, you got it. But now what we're going to do for the tibia is a little bit different type of balancing that people have done before, right? So we're going to take the tibia through a range of motion, but not through the varus valgus stressing right away. We're just going to put it through a full range of motion. And that's going to basically give us our model of the tibia. We're basically generating the tibia from that motion. And then we'll run you through the varus valgus at different angles. And that'll help you understand the tension. And instead of the surgeon sitting there and doing all this math in 6 degrees of freedom, which some of you like to do, and you can still do it if you want, we're going to allow you to jump right to the screen with our recommended positioning and angles, slopes. In KA, there's this trend of slope adjustment, and there's an issue with sometimes recutting to get the optimum balancing instead of doing a ligament release. So instead of a cut and then a recut, we're really going to allow you to find that optimum place and slope. And very often medial and lateral slope are different because you want the one condyle to swing back more. But you can still take control and make any changes you want to make. We'll have those curves we'll have that as an option. So if you want to see curves, we can bring you curves.
Question. So if you want to do mechanical, you can do mechanical.
Yeah.
If you want to do kinematic, you can do that. For those of us that like kinematic light,
Okay.
how does that work?
Kinematic light is
Functional alignment?
functional.
I think they call that?
Yeah, functional.
Functional.
So like, is that like
Crazy
kind of
on
like
the
gap
tibia.
balancing?
You're not going crazy on any of it. You're just getting it closer. And probably more soft tissue releases because of it.
What's great about it is that the math is all a little bit different, but ultimately very similar. So as we produce more and more versions, we're gonna make it very custom to you.
Yeah, I got you.
It's a good lead into my next point. We're building an AI to learn surgery, and we're doing it from surgeons like yourself, world-class master surgeons who understand surgery, and we're recording aspects of the surgery to understand how you do these things and building AI models around that. Eventually, after maybe 20 to 50 to 100 cases, we would know what you're doing and what you like. We'd help make sure your scrub tech was ready with the next instrument, what was coming next. We're really looking to apply those technologies so you don't have to retrain it every time.
Understood.
So it won't be a single user interface, you'll all have your own.
Does muscle or soft tissue of the patient affect the registration that these lights are doing, or not really?
Different approaches make it, a little bit more challenging.
Yeah.
Fortunately, we only need a second of the bone in a stable position to capture most of it. Even if you're using a different technique, which doesn't show a lot of the femur, we're able to do that. So far, we've done the traditional ones, parapatella, medial parapatella.
No, I meant the size of the patient, how much
size
muscle
of the
there is. It's using those lights, I guess, to capture points. Does that affect the capturing of?
No,
No, just goes right.
Yeah,
Doesn't matter.
as long as you can see the bone, visually as you can see it, then we can see it too.
Nothing in the OS. Some of the navigation systems and different things out there get affected by the other lights in the room or different
Overhead
devices.
lights and all that.
Yeah,
Overhead
we've actually
lights,
looked at all
everything.
kinds of exposures. We're a startup, so we can't afford a big expensive operating room light that's like 100 grand. So we got a warehouse light that will blind you if you turn it on. So we turn that on to see how it looks. And we've played with exposure, ultimately because we're using very traditional cameras in this, very advanced cameras, but very low cost. We're able to deliver adjustments by capturing. The other thing that's a little bit different, and I don't know what it will end up costing once we partner with the device companies, but we kept the cost of this very low. So this is designed for the ASC. It's in the range of 5 figures, low 5 figures for the cost. If you go into a higher end version, a little bit halfway to 6 figures. So we're talking
Is there a
about,
discount for 3?
oh yeah, you need 3. So there'll be a version that goes room to room by itself. This will find its own way. There'll be a version that you can just pull with a cart. The problem is they're basically half the cost. So you can either get 2 that, or you can get 1 that moves from 3 different rooms.
Disposable.
I was going to say, how does it address extra articular deformity?
Extra articulate.
Yeah.
The tibia
So
is
there's some
has a
damage.
malunion
Tibial
down
fracture,
this.
yeah, malunions, femur, tibia.
Yeah. So I'd say that this is probably going to cover a lot of the basic cases. When you have challenging cases, you'd have to make a decision. So if there was extra bone loss, you'd have to accommodate that in one of the steps.
Did you have metal around, or like screws that were previously placed? Does that affect any of this registration?
Not at all.
Yeah.
Not at all. Because it's looking at things the way you see things. So if you see it and can interpret it, we can too.
Disposables for each case on top of the.
There'll be a Lisa drape, and then we're letting the device companies we're partnering with to decide what becomes disposable, what becomes reusable. The trend is, I'll say that a lot of the companies, what we're hearing, they don't want to spend a lot on disposables. They want it to be low cost for you guys, and that's our goal too.
You're referring to that as a robot? Is that because it's making adjustments
Yeah.
like by itself? So
That
it's
is a robot. That is a robot. It's a very small robot, but it still counts. It's not an arm, right? But the nice thing is this technology is very transferable. So some of the partners we're talking to, they have arms, and we can incorporate our vision system into their arms.
You can apply it to hips and shoulders and everything
Great
else.
question. Absolutely. So our founding surgeon is Joe Iannotti, Dr. Joe Iannotti. This was his IP in the beginning.
And shoulder.
Yeah, so we're definitely going to do shoulder. Ankles also in our sites. And we can do hip with some effort. We can see more. It'd probably require a few more steps for us to get to hip.
If you want to recut, how does this work?
Great question. If there's any pins still in, you can make that recut just by going back to the robot with an
And
additional
then it'll
recut.
adjust the
You
cut.
can add another millimeter or 2 from the plan. You just have to go back and change, like if you came back to the screen and went to 11, and 11, it would recut with that new
But if
extra
the pins are out and you want to recut down the road,
we got another one for that. So
Okay.
it would use the cut and make an adjustment off of the cut. So it's a different instrument. We haven't yet fully fleshed out. But that's a good point. There's a lot of that going on. I want just a millimeter from this side. Right now you're doing that one side and then you're kind of coming in freehand and
Right.
taking the sliver. And you guys are amazing at it, but not everyone can do that.
It's pretty cool, right?
Very
cool.
Very interesting
Um,
technology.
So Peter, it just every year it just gets better, better, and better. Iterative improvement. Well done. So for the audience watching this, for surgeons out there that would like to be part of that journey, helping the computer learn how they operate, right? How do they connect with you?
Easy way is to connect on LinkedIn, say hi, shoot me an email at peter@redefinesurgery.com. Or contact Kevin, he knows me. He'll send a text message.
Phenomenal, right?
Yeah,
I can't wait to see what the next 12 months holds. Every month, every year, it just gets better and better. Thank you so much for opening up your booth to all of us and letting us see this. And
Thanks for
what a great in-service and what a great project y'all put together.
Thank you. Appreciate it. Thanks, guys.
what's the